Welcome to Group 3 presentation. Along with my group mates, we will be discussing the Rsa Algorithm or RSA algorithm. This presentation covers the following topics: the RSA definition, examples, how does the RSA work, its features and characteristics, purpose, advantage and disadvantage, and the encryption formula. First, what is RSA? RSA algorithm is an asymmetric cryptography algorithm. There are two different keys used in asymmetric encryption: the public key and private key. As the name describes, the public key is given to everyone and private key is kept private. The public key is used for encrypting the data and the private key is used for decrypting the data. The following illustration highlights how asymmetric cryptography works. For example, when a client sends its public key to the server and requests for some data, the server encrypts the requested data using the client's public key and sends the cipher text, which is the encrypted data. And when the client receives the encrypted data, it will decrypt the data with its own private key. Since this is asymmetric, nobody else except browser can decrypt the data even if a third party has public key of browser. And also, both keys belong to the receiver.
So how does the RSA algorithm work? So we have four major steps. The first one is to generate the RSA modulus. The second one is to derive the numbers E and which stands for encryption and D for decryption. And then step 3, we are going to generate the public key. And step 4 is the generation of the private key. To further understand these steps, an example is explained. So here is a simple explanation of the RSA algorithm. Since that algorithm relies on the concepts of public and private keys, we have to generate those first. So the keys would have pairs of numbers. So we are going to determine the value of E, D, and N. E stands for encryption and D stands for decryption. So the first step in this algorithm is to pick two random prime numbers. So for this example, I would use 2 and 7. Of course, in real life situations, the two random numbers would be hundreds of digits long, so it's harder to decrypt. Now, the second step is to get the product of P and Q. So 2 times 7, that would be, of course, 14. So this 14 is our N. So this is our RSA modulus. So this is very important. So now we're going to put it here, 14. Now, for the third step of the algorithm, we have to determine the phi of N. So this is based from the Euler's phi function. But since we already have this formula, we just have to substitute and we don't have to worry about that. So the phi of 14 is equal to 2 minus 1 and 7 minus 1. So this will be equal to 6. So this will be used later on in our algorithm. So the phi of 14 is 6, okay? So that's on step 3. So the fourth step is to get the value of E or choose the value of E. So in choosing the value of E, we have to follow these two rules. The first rule is that E should be greater than 1, but less than phi of N. So what is the phi of N that we have solved earlier? That is 6. So E should be greater than 1 and less than 6. So the options that we have for letter E are 2, 3, 4, and 5. Now the second rule is that E should be co-prime with N that was solved earlier, that is 14, and phi of N, that is 6. So co-prime meaning they do not share common factors. So does 2 share common factors with 14 and 6? Yes, so we have to cancel that. 3 also share common factor with 6 because 6 is 2 times 3. So 3 itself, they have common factor. 4, of course, they have a common factor with 14 and 6. 5, they do not, 5 doesn't have a common factor with 14 and 6. So the value of P now is 5, all right? So this is only easy for small numbers, but of course, for bigger numbers, this is impossible to solve. So the fifth step is determining the value of D by following this rule. So D, when you multiply to 5 and get the modulo of phi n, 14, 6 pala yun, 6, it should be equal to 1. So what would be the value of D such that when you multiply to 5 and divide it to 6, the remainder would be 1, right? So there is no easy way to solve this. So it would be solved by trial and error. So here the numbers are already laid and solved. And the highlighted ones, these are the possible values of D. We have 5, 11, and 17. So for instance, we substitute 5 to this place. So 5 times 5, 25 mod 6 would be equal to 1. It's also all right with 11 and with 17. So for this example, we would use 11. But in real life equation, the higher the number, the better. So since 11 times 5, 55. 55 divided by 6, 55 divided by 6 is equal to 9. And the remainder is 1. So I will choose 11. We could also choose 5 or 17, but for this example, we would choose 11. Okay, so now we have already generated our public and private keys. So after generating the private and public keys, we could now use this for our cryptography system or something. And then now, so our public key that was solved earlier is 5, and 14. Our private key is 11 and 14. Now, how are we going to use these keys? So in RSA encryption, we could use this to encrypt this message. For example, I want to send the message B. So the first thing that would happen is that, of course, to convert this to number, because that's how computers understand data. So B is the second alphabet, so that would be 2. Now we are going to use that as the base, 2 raised to 5, which is our encryption digit, and use the RSA modulus, which is 14. So 2 raised to 5 is 32. Mod 14, that would be equal to 4. Because 32 divided by 14 is 2, remainder 4. So 4 in our alphabet, that is letter D. So now our ciphertext is D. So ciphertext will be the text that will be received by the receiver, the encrypted text, okay? So now, once the receiver received this ciphertext, he could decrypt it using the private key. Now, the private key is private, and the public key, anyone can have this key, but the private key, it should be kept private. So to decrypt the ciphertext, it's the same as the method that was done earlier. We have to convert this to number. So D is the 4th letter of the alphabet, and use that as the base. 4 raised to the decrypt digit, which is 11, and use the modulus, RSA modulus, which is 14. So if you solve this, it would be 2. So now, what is the second alphabet? That is letter B. And that's how we use the RSA algorithm for encryption and decryption. So what are the key features of this algorithm? The first one is that this algorithm is very popular. It's a very popular exponentiation in a finite field over integers, including prime numbers. The second one is that the integers used by these methods are sufficiently large, making it difficult to solve. As I said earlier, the prime numbers, the 2 prime numbers used are like hundreds of digits long. And the third one is, of course, there are 2 sets of keys in this algorithm: the private key, which should be kept by the receiver only, and the public key, which everyone can have.
Now we move on to the characteristics of RSA algorithm. The first characteristic would be it is a public key encryption technique and it is considered as the most secure way of encryption. The second would be it is safe for exchange data over the internet as it also maintains the confidentiality of the data. And lastly, RSA has high toughness as breaking into the keys by interceptors is very difficult. What is the purpose of this RSA algorithm? The first would be the modern computer employ the RSA algorithm to encrypt and decrypt messages since their properties allow public keys to be shared without endangering the message or revealing the private key. The next one would be it is mostly used in transferring data security. And lastly, it also allows for public key encryption used to protect sensitive data as it is delivered over to an insecure network.
These are the advantages of using RSA algorithm. The first one is RSA algorithm is easy to implement because it provides a method of assuring the confidentiality, integrity, authenticity, and non-repeatability of electronic communications and data storage. The second one is RSA algorithm is safe and secure for transmitting confidential data since it uses complex mathematics. The third one is since RSA algorithm has a complex mathematics, it is hard to crack since it involves factorization of prime numbers, which are difficult to factorize. The fourth one is RSA algorithm uses public key to encrypt data, and the key is known to everyone. Therefore, it is easy to share the public key. The disadvantages. Um, the first one, it may fail at times because complete encryption requires both symmetric and asymmetric encryption, and RSA algorithm only uses symmetric encryption. The second one is RSA algorithm can be very slow in cases where large data needs to be encrypted by the same computer. The third one is it requires a third party to verify the reliability of public keys. Data transferred through RSA algorithm could be compromised through middlemen who might tamper with the public key system. The fourth one is decryption requires a significant amount of processing at the receiver's end.
Hello. Today I'll be talking about the encryption formula and decryption formula of the RSA algorithm. So basically, these two formulas are very straightforward, and it uses a public and private key when encrypting and decrypting. So consider a sender who sends the plain text message to someone whose public key is NE. To encrypt the plain text in the given scenario, use the following syntax. This is the same with decryption formula, only that the decryption formula we have D, where D is the private key, and the formula changes with CD mod, and mod meaning modulus. To further explain these two, I prepared an example of the encryption formula and decryption formula. So say that we have the public key, and this is the E key, 9 and 22. This is also to denote that this is E and N. Okay, so our text is B. We'll just use a single letter to keep it easy to understand and pretty concise. So to encrypt this, we use the formula C is equal to P raised to E mod N. So we go ciphertext is equal to P, which is B. Okay, wait. Plain text, which is B raised, which is 2, because B is equal to 2 raised to 9, 22, mod 22. Okay. This gives us a ciphertext of a cipher number of 2, of 6, and this 6 is equal to F. So how did I come up with F? F and B is technically the position in the alphabet where these letters lie. So B being 2 and F being 6. Yeah. Now to decrypt this, one has to have the private key, which is D. So this is private. And to denote, this is D and this is N. So we have so we're going to use the formula P is equal to C raised to D mod N. C is our ciphertext, which is 6, so F is equal to 6. And D is 19, while N is 22. So if we do the formula, we get plain text is equal to 6 raised to 19 mod 22. 6 raised to 19 mod 22. This will give us a remainder of 2, which becomes 2 is equal to b as we have here in the plain text. So how do you get the keys? The process is just very simple. I have it down here. So first you'd want to get you can go. Okay, so first you'd want to get two prime numbers. We'll name it as P1 and P2, 2 and 11. Multiply these two and you get 22. So that's 2 times 11 is equal to 22. This is our n. As you can see, it's here, 22, 22. Okay. Moving on, we have the number of coprime. So the number of coprime is p underscore 1, p minus 1. So that's n coprime is equal to p underscore 1 minus 1 times p underscore 2 minus 1. This becomes coprime is equal to 1 times 10, which ends up being 10. And to get E for the encryption, E, you should have the following. It should be under the following actually. Greater than 1 and less than the number of coprime, so less than 10. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can see that 10 is an even number, so we remove all even numbers, including 1. Oh, it's not even, is it? Anyways, there we have 3, 5, 7, and 9. As you can see that 5, it should be coprime with n, which is 22, and number of coprime, which is 10. So we remove 5 because it has a value in 10, and we have 3, 7, 9. So I'll pick 9 for the sake of explaining, and that is our E, which is the lock. So this becomes the public key. The key is equal to 922, which is the one we have up here. Now how do we get D and how do we get the private key? So the private key isn't random, it's actually D is equal to DE mod number of coprime is equal to 1. So if we do this, it becomes D 9 mod 10 is equal to 1. 10 is the number of coprime and 9 being the public the E. So how did I get 19? Pretty much to get 1 is that you have to do multiples of 9. So 9 times 2 is 9, 18, 27, 36. This is if you mod this, it becomes 9, 8. If you mod this by 10, it becomes 9, 8, 7, 6, etc. until 81, which is 1. Now you can do this, and you can have it as 9, as long as it's equal to 1. So D can be 9, but then you don't want it to be easy, so you do it again, and you have 19. Yeah, I have 19, where it's still equal to 1. So that's where the key D comes from, 19 and 22. That'll be all for the two formulas and for our presentation of the RSA algorithm. Thank you for listening.